Alright, well, good afternoon and welcome back to another exciting day in mathematics. Whoop, whoop. Let me just double check that we are live. I'm waiting for the feed. Nothing yet. I think it looks like now it's up and running. Okay. Alright, I'll give a little bit more time for those of you that are going to join us live. In the meantime, once again, welcome back. And our warm-up for today is 112. So go ahead and copy that. Example 1 reads, rewrite each expression. We have part A is a to the power of -2, and then part B is 5 to the power of 0, and then part C is 1 over x to the power of -4. Number 2, it says if x to the third times x to the fifth is equal to x to the 3 plus 5, which is x to the 8th, then rewrite 2 to the power of x plus 5. Let's see how you do with that. Number 3, it says graph f of x equals x squared using the domain -2, -1, 0, 1, and 2. And then it says then transform the function given g of x equals x minus 4 to the second power minus 3. And number 5, it says look at the figure below, find a pattern and write a rule. How many squares in the 10th tenored my bad on the 10th figure? And we have figure number 1 has 1 square, figure number 2 has 4 squares, figure number 3 has 9 squares, and they're in a squared form. So go ahead and copy that. You can I'll give you some time. And once again, those of you that have been uploading your home play and finishing the activities on Nearpod, thank you, appreciate it. You guys are the bomb. Bam. And let's see, where are we at? Who's on right now? We got Avery, Don Avery, love you too. Jay, what's up, Jay? No, you're not gonna struggle on this. We got this. Come on now. I'll do again to the restroom. Ya vas a empezar. Let's go. Let's get to work. Oh my goodness. Anyways, what do you guys think about that little screen I put in the video? Pretty good? Yeah? Thumbs up? Raya, miss you too. I miss you, all of you. Love you guys. Miss you. Aww. Alright, so by now you should be almost done copying the warm-up. Yes? Give you guys 2 more minutes. 2 more minutes and then I'll go over it. Also, BTW FYI, if you know any the students from the other classes, the Algebra 2 classes, Mr. PJ's or Mr. Scott's. Let them know that we are uploading lessons every week. So I'm going to try and upload at least 2 lessons, one on Tuesday, one on Thursday. So like that, it give you plenty of practice and plenty of time to do a lot of help and work at the house, like wash dishes, vacuum the house. Bam, let's go. How about cook some tortas or some tacos? What's up, Aldo? Some tacos? All right. Jay, you done? All right. So here we go. I'm going to get started. So for number 1, it says rewrite each expression. We have part A, and it says a to the power of -2. Reminder, can we leave this with a negative exponent? No, right? So therefore, how do we change this? Well, remember that we need to send it to the denominator, and the exponent becomes a positive. So what do we write on top? That is correct, a1. There you go. All right, how about part B? Part B, we have 5 to the power of 0. And who remembers anything to the power of 0 is? That's right. This is 1. Anything to the power of 0 is 1. All right. Part C. Riot, you're getting hungry. We just started. Anyways, whoever has a snack, you may have your own snack. I had my snack earlier. So anyways, let's go to this one, part C. It says 1 over x to the power of -4. So what do we do with this one? Well, we distribute the negative exponent. This is the exponent of 1, exponent of 1, to distribute. So this becomes 1 to the -4 over x to the -4. So what do you guys think? If this is a negative, it goes where? Down here. That is correct. But this one's already a negative and it's in the denominator, so what do? That's true, we send it to the numerator and it changes to a positive. So, let me make some space here. What is 1 to the 4th power? Well, 1 to the any power is 1. X to the 4th. And what is x to the 4th divided by 1? X to the 4th. Is it coming back? Yeah? Okay, good. Miss you too. Who's that? Blue XD. I don't know who it is, but bam, miss you too. Come on. Alright, let's go to example number 2. And it reads, x to the 3rd power times x to the 5th equals x to the 3 plus 5 because of the rule of exponents, which is x to the 8. So look at this. We have 2 to the power of x plus 5. So how can we write this? We can't combine x plus 5 anymore. It's already there. Can we go backwards? Yeah, let's go backwards. So what would this be before it became this? All right. Yeah, so it's 2 to the x times what? That is correct, 2 to the 5th power. And that gives us that. And we can rewrite it like this. Alright, and right now I'm giving you skills that we're going to need for the next step in regards to the concept we're starting today. But this is stuff that you need to remember because we need it. Okay? Alright, let's go to number 3. Number 3, it says graph f of x equals x squared using the domain -2, -1, 0, 1, and 2. So let me get a coordinate plane on this side. x over. Alright, there it is. And let's start. Do I need to make a table? No, I can just start with negative 2. What is negative 2 squared? Negative 2 squared is positive 4. Yeah, 1, 2, 3, 4. What is negative 1 squared? Negative 1 squared is 1. What is 0 squared? 0. 1 squared? 1. And 2 squared? 4. Alright, so there it is. Let's see who's here. Isabella. Welcome. Miss you. And Aldo, what's the question? I did not my home play because I did not understand it. What? For this one? That's why we're barely going to do it. Alright, so let's graph the transformation. Before I move on, look at it. So this was the parent function over here, but then something happened to it that they want us to do this. So before I move on, tell your neighbor, my bad, type it in there, what's going to happen to the function according to what we have here. I'll give you some time. Type it in, please. I'm doing good, Isabella. Isabella. Just working like always. Can't stop my brain. Alright, so as you're doing that, so this tells us that the whole function is going to move what? Let's see, I see move to the right 4 and 3 down. Thank you, Raya. That is correct. To the right 4 and 3 down. So every point we move it to the right 4 and 3 down. To the right 4 and 3 down. Give me a second. So 1, 2, 3, 4, and then 1, 2, 3, which is this one. This one, 1, 2, 3, 4, 1, 2, 3. This one, 1, 2, 3, 4, 1, 2, 3, and so on and so forth. So you guys remember that, right? So our new function is over here. Hands, have you got that? Bam, it's Isabella multitasking, cleaning and watching. Let's go. Alright, let's go to the last one. It says, look at the figures below, find a pattern and write the rule. How many squares in the 10th row? So for these, whenever we get some of these guys, this is what I want you to do. Make a table. And then this one is figure 1. That's going to be our n. This will be our f of n. So figure 1 is 1. Figure 2 is 4. Figure 3 is 9. And dot dot dot, and they want us to find the 10th figure. Alright, we'll look at it. So let's see what's happening from here to here. From here to here, is there anything? No. Can we do anything to this to get this, to this to get this, to this to get this? Who's got it? What do you guys think? Yeah. Do you notice that if we do 2 times 2 is what? 4. 3 times 3 is 9. Therefore 1 times 1 is 1. So if we're multiplying it times itself, how can we rewrite it? Our rule would be f of n equals what? N to the, second power. because we multiply times itself. So therefore, plus 5, Raya, I don't think it would. Yeah, it works here, but it doesn't work if I do the next one would be 4. If I do 4, the next number would be 16. So therefore, it doesn't add the 5. Okay, Big Mike, welcome. So they want us to find the 10th term. So here we're going to do f of 10 equals 10 squared. So this is f of 10, sorry, which is 100. All right, good practice. All right, so let's move on. So your home play for tonight is on pages 643 and 644 all only. Bam, let's go. Pages 643 and 644 all only. And your Nearpod code to turn in your home play is on QVUDO. Nearpod code QVUDO. All right. Once again, pages 643, 644, write that down. And your Nearpod code to turn your home play in and also to fill in the rest of the slides that I included is QVUDO. Alright, let's move on. Alright, get a Cornell note ready. Our objective for today, I can graph exponential functions. I can graph exponential functions. So by now, you should know what the main idea is, or the main concept, which is, that is correct, exponential functions. So I can graph exponential functions. What are exponential functions? Alright, so in your FAIR model, write in there exponential functions. I'll give you a little bit of time to create that really quick. Isabella, yeah, I miss you guys too. Love you guys. Miss you guys. Hopefully you guys are doing a lot of work at home. Yeah, let's go. Alright, so exponential functions, what are they? Definition. A function written in the form f of x equals b to the x power. Or g of x equals a times b to the x minus h power, close parentheses, plus k. Where b has to be greater than 0, but b cannot equal 1. And where the x is an actual variable. X has to be a variable. Write that down. Alright, examples. Here we go. Here's an example of an exponential function. F of x equals 2 to the x power. Let's see, according to the definition, it says it needs to look like this. Does it look like that? Yes. B, which is the base, has to be greater than 0. Is this number greater than 0? Yes. And the x, or the exponent, has to be a variable. Is the exponent a variable? Yes. So this is an exponential function. Let me show you another example. G of x equals negative 2 times 3 to the x power. And once again, it's either this or this. So it's starting to look kind of like this. So let's look at the x. Is the exponent still a variable? Yes. Is the base still a number greater than 0? Yes. And now we have a number multiplying outside, or the coefficient, which now represents which variable? A. That is correct. Alright, and the last example. G of x equals 5 times, parentheses, 2 to the x minus 3 power, close parentheses, plus 4. And once again, is the base, or b, greater than 1? Yeah, it's a 2, it's greater than 1. Is the exponent a variable? Yes, and now it's being subtracted, but it still has a variable, so it still qualifies as an exponential function. Copy those, give you some time. Alright, so non-examples. Check this out. So now that we know what exponential functions look like, let's look at non-examples. I'm given 5 parentheses 2 to the x minus 3 close parentheses plus 4. Before I move on, think about it. Why is this not an exponential function? Alright, so I'm pretty sure you notice that it doesn't have a what? Equal to f of x or g of x, so therefore this is only a what? An expression. That is correct. Man, you guys remember. Let's go. I'm reading your mind. I'm a Jedi master. Bam. Next non-example. Let's see. F of x equals x squared. Now look at this one. This one's interesting. But this is not an exponential function. So think about it. Why is that one not an exponential function? Look at the definition. Look at that one. Look at the examples. That one. Who's got it? Anyone? Okay. I'll wait a little bit more. Alright, so hopefully you guys saw that this one is not an exponential, because the exponential functions, the base here needed to be a number greater than 0, but this is a variable. And here the exponent needed to be a variable, and it's a number. So therefore that's why this is not an exponential function. Okay? So with that said, what makes exponential functions exponential functions? Give me some hashtags here. Hashtag what? Hashtag what? Hashtag what? According to what we saw that they weren't and what they were. Give me something here. Alright, so let's see. I wrote hashtag, it has to be a function. What is the other? Hashtag base plus number, not 1. Oh, so the base has to be a positive number, my bad. Base positive number, not 1. Okay? And variable exponent. So hopefully you Raya, oh yeah, hashtag exponents, hashtag functions, hashtag no expressions. That's true, I forgot about that one, so write it in there. Hashtag no expressions. Alright, let's move on. Alright, so let's revisit this general transformation. Writing utensils down really quick. Look up to the screen. It says revisit our general transformation rule. G of x equals a times f of 1 over b x minus h close parentheses plus k. And I think we're missing here a parentheses in front of the x. But you guys remember this? Yes? So think about it. What does a do? What does b do? What does h do? And what does k do? You don't have to answer, you just need to keep it in your noodle. Okay, so now look at the new function, general form function, that we are going to be looking at. G of x equals a times b to the x minus h power, close parentheses, plus k. So do you notice that there's a lot of similarities with this and this? Yeah, because what did I say? That as long as we understand the main idea in regards to transformations and the general rule, it applies to any function. Now you haven't seen the function in regards to what it does and what it doesn't do, but I'm pretty sure if I was to ask you what each part of the function of the graph, what is it going to do, you would know what to say. So first of all, what does k do and what does h do? Think about it. Yeah. So we remember that k goes what? Up and down. And how about h? Side to side. That is correct. Alright, how about a? What does a do? Exactly. It stretches or compresses, but in which direction? Yeah, that is correct. In the vertical. So what does B do? That's right, the same thing, stretches or compresses, but this one which way? Horizontally. Good job. And we haven't even seen the graph, but we already know what it's going to do, right? Bam, let's go. All right, let's move on. Did everybody copy that? Yeah? All right. All right, let's move on. Example 1. It says, part A, it says graph f of x equals 2 to the x power. And then we are given the table with domain -2, -1, 0, 1, 2, 3. And then we have f of x, and we're going to fill that in. Copy that. I'll give you some time. And if you have graph paper, then get that in front of you. If you don't have graph paper, then at least create a coordinate plane that looks something similar to that. All right. So here we go. I'm going to go ahead and fill this in, and I'm going to use blue for this part, like that we can do the original. This is what we call our parent function. Parent function. All right. So f of x equals 2 to the x power. So now instead of x here, the exponent, what am I going to substitute in there? That is correct, -2. So let me show you that. So it's f of -2 equals 2 to the -2 power. Does everybody see this? All right, so let me zoom in really quick so you guys can see what I'm looking at. All right, so look at this part. We have 2 to the -2. Can we leave this to the negative exponent? No, we need to make this into a positive. How do we do that? Send it to where? The denominator. It becomes a positive exponent. So what do I write on top? Yeah, a 1. So therefore, 1 stays the same. What is 2 to the second? 4. So that goes right there. Alright, so you're like, oh, this is easy, Mr. Q. I know, we just needed the practice to remember about the negative exponents and such. So let's do the next one. F of, what is my next value? -1 equals to 2 to the -1. Alright, so once again, can we do with the negative exponent? No. 2 to the first over 1. 2 to the first power, anything to the first power is the same number, so this is 2 and this is 1, so this is 1/2. Alright, next one, f of 0. 2 to the 0 power. What do we know about any number to the 0 exponent? Yeah, 1. That goes right there. Next one, f to the first power, which is 2 to the 1. What is 2 to the 1 power? 2. That is correct. That goes right here. And the last, the next value, not the last one, the next value, f of 2, which is 2 to the second power, which is 4. That goes right there. And the last one, f of 3, which is 2 to the third power. What is 2 times 2 times 2? Right, 8. Right there. How are we doing? Good? Yes, Mr. Q. All right, good. Let me zoom out. There it is. Alright, so let's plot our values. We have -2, 1/4. -2 and 1/4 is about right there. -1 and 1/2. -1 and 1/2. 0 and 1. 1, 2. 2, 4. And 3, 8. Now before I graph it, I need one more piece. And look what I'm going to do. I'm going to write down here, I'm going to write HA. Who remembers what HA stands for? Yeah, horizontal asymptote. Horizontal asymptote. So I'm going to write what? Y equals. So question, is there a constant after the 2 to the x power? No, if there isn't, then what would be my horizontal asymptote? Yeah, 0. So I plot that here. So what does that mean? That I have an invisible line or a asymptote going through 0 that looks like this. And why do we need that asymptote? Well, because that's going to indicate that we cannot touch that line. So when we graph our exponential function, such as this, we can start as far as we want, going through those points. There you go. And that's how you graph an exponential function. And I'll put arrows here. So it's going to keep on going. Does it ever touch the asymptote? No, it will never touch the asymptote. So let's talk about domain and range. Domain. You're like, oh, here we go. I know. Here we go. Domain. I'm going to write it in interval notation. So this arrow keeps going to the left. That means it keeps going to what? Negative infinity. This is going up, but it's going to the right, which means for the x values, it's going to continue going to what? Yeah, positive infinity. So how's my domain written using interval notation? Yeah, parentheses, negative infinity, comma, positive infinity. All right. So that's the domain. And by the way, from this point forward, this never changes. Put a little asterisk, put a little heart. That never changes. Tell your neighbor what I just said, or whoever's there with you. Your parents, are they watching? Let's go. That never changes. Let's go to the range. Range. So think about it. For the range, that means it's the y-axis or the f of x. Where does it start? Let's see, this arrow continues going downward, but could it ever touch this asymptote? No. And what was that? 0. Okay. And it goes upward to what? Positive infinity. So my range is 0, comma, positive infinity. Does it ever, should I do a bracket here for 0? No. Why not? Because it's an asymptote and it doesn't include that point. All right, how we doing? You see, Jay? You said you weren't going to understand this. This is easy. Let's go. Raya, my neighbors are my stuffed animals. Okay, that's all right. That's good. We'll just let them know what's up with that. All right, so we're done with this piece. And I do want us to add a little bit more to that same graph. So let's do example 1b. 1b. Here we go. Write this down. Graph g of x equals 2 to the x minus 1 power. I'll give you some time for that. In the meantime, I'm going to graph the original one, which was this one. What did we say it was? 1/4, 1/2. This is 1, 2, 4, 8. And that never changes. -2, 1/4, 1/2, 1, 2, and 4, and 8. And yeah, I didn't include the asymptote right now. I just want to make sure that we go through the other one so you guys can see the other part. All right. So here we go. So let me include the asymptote just to make sure that we remember the process. Here it goes. All right. So let's go over this one. I'm going to do this one in red. So I'm going to write this over here. So it's g of, what is my first value? -2 equals to 2 to the x minus 1. But instead of x, what am I going to write? -2 minus 1. So this is 2 to the -3. Can I rewrite it like that? No. Let me make some space here. So this goes in the denominator, so it's 2 to the third power and 1 on top. So this is what? 1/8. That goes right there. Pretty good. Let's go over the next value, the -2. So g of -2 is 2, and then we have, no, it's not -2, my bad, -1. I did that to see if you were paying attention. Bam, -1. So it's -1 minus 1. So this becomes 2 to the -2, which is Isabella says that she's you miss class and you're bored at home. Well, yeah, I mean, you got to make it exciting at home. Do, like, put some music on or something. So this is 1 over 2 to the second, and this is 1/4. That goes right there. Let's go with the next value, which is 0. G of 0 equals 2 to the 0 minus 1, which is 2 to the -1, which is 1 over 2 to the first, which is 1/2. Let me move this up. Next value, 1. G to the first. G of 1 is 2 to the 1 minus 1. What is 1 minus 1? 0. So what do we know this is? 1. Next one, g of 2, which is 2 to the 2 minus 1, which is 2 to the 1, which is 2. And the last one, g of 3, which is 2 to the 3 minus 1, which is 2 to the second, which is 4. How are we doing? Yeah? Alright, so let's plot those points. Let's see. We got 2 and 1/8, -2 1/8, -2 and 1/8. Let me zoom in so see where 1/8 is at. -2 and 1/8. It's about right there. It's close to the 0, but it's not quite. -1 1/4, -1 1/4. 0 1/2, 0 1/2. 1 1, 1 1. 2 2 and 3 4. 2 2 and 3 4. 2 2 and 3 4. All right. Okay, let me zoom out. see, what do you guys notice? Do you guys notice anything? Hold on. Look at this point. Look at this point, and then look at this point. Look at this point, look at this point, look at this point, look at this point. What can you conclude with that from the original one to that one? Yeah, it went to the right, to the right, right, right? So let's see if it's true. What do we know about this transformation? That this is our what? Our h, and this tells us to go which direction? To the right, 1. What if this was a positive 1? It would have moved which way? To the left. That is correct. How are we doing? Fairly simple, right? So look at this last one. Part C, g of x equals parentheses 2x minus 1 power, close parentheses, minus 5. So before I move on, let's see. What were the values here for negative 2? Negative 2 was 1/8. Negative 1 was 1/4. 0 was 1/2. 1 was 1. 2 was 2. And 3 was 4. So let me plot that really quick. That's our last one that we did. And once again, it's negative 2, 1/8. Negative 1, 1/4. 0, 1/2. 1, 1. 2, 2. And 3, 4. In our invisible asymptote, it's right there. Okay. And why is it right there? Because it doesn't have anything here after the exponent, any constant. So look at this one. Now before you fill in the table, and I'm going to have you do that by yourself, this is our last one that we did over here. So what do you guys notice from here to here? Yeah, that this is in parentheses, and what's outside? Negative 5. So question, this one had the asymptote at 0. So did this one, because it didn't have anything outside after the exponent. Question, do you know what the asymptote is on this one? Yeah, negative 5. So that means I'm going to graph my asymptote at negative 5. So what does that mean, Mr. Q? That the same points that we have here, after we plot them, they're going to move in which direction? That is correct, 5 steps down. So I'm going to take this one. So this one is going to go 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5. How about this half? Go half here, 1, 2, 3, 4, 5. And so on and so forth. There it is. Let's see, Isabella. German Shepherd puppy. Okay, we'll do. No, I don't have tutor in afterlife. All right, so I'll let you do the table for that one by yourself, but this is what you should get at the end. Okay, so we're down to the last part. Copy this one, example number 2, and it says graph g of x equals 1/3 to the x power. And that one it's gonna be a challenge one. I'm not gonna go over it with you. I just want to see if you can actually your noodle kicks in, and once you substitute values and you fill in the table, you graph it and see what you get, and see if think about everything that we practiced on the warm-up, what we did right now with the graphs, and see if you can actually finish that table and do it by yourself. So just copy that. Once again, example 2, part A, it says graph g of x equals 1/3 to the x power, and once again the domain given is -2, -1, 0, 1, 2, and 3, and f of x, change that to g of x, my bad, and then just graph it. All right, so for that part, you're going to do that at home again by yourself, and I do want you to copy this table. Example number 3, it says, what happens to the graph of the parent function f of x equals b to the x power given the general exponential function with all parameters? And the general exponential function is g of x equals a times b to the x minus h power, close parentheses, plus k. And then you copy this table, a, b, h, and k, which are all the parameters. And then you're going to write in here, once you have the table, what happens to the graph, the original graph, when a is a number greater than 1, greater or equal to. When b is a number greater than or equal to 1. H and k, same thing for when the value is less than 1 or less than or equal to 1 for a, for b, for h, and k. And what happens to the graph when a is 0, b is 0, h is 0, and k is 0? But try one at a time, not all of them at the same time 0, because then you're not going to have anything. Same thing here. Try one first at a time. Do a by itself and see what it does to everything. And then from there, the next, and the next, and the next. And just play with it. And you're saying, oh, how do I do that, Mr. Q? I'm going to give you a code for Desmos, so you can do that on your own. And remember how we did it in class? You would go to Desmos and then you move the levers and stuff. Yeah? Okay, so did everybody copy that table? All right. You got it? So greater than 1, less than 1, and 0. So here's your code for Desmos. A2P K3E. And you don't need to leave a space, and they don't need to be caps. It can be low caps. And all together. A2P K3E. And that's the password for Desmos. And remember, to log on to the student Desmos, you need to type in the browser for your internet, student.desmos.com. Type in that code, and then it's going to ask you to log in using Google. You don't have to log in. At the bottom it says go in without logging in, so you click on that, but it is going to ask you for your name, so make sure you type in your name, so like that I know who went to do the activity. Alright, and after that, just answer, it's got some questions in there that you need to answer at the end. Remember the poll, make sure you finish that. There's some screens that require you to lock your toolbar. So once again, take a picture of your warm-up, take a picture of your home play, take a picture of your notes on each of the slides that I gave you the slide for. I want to see your notes, and submit that. And also, I have a message from Miss Hawk, the counselor, and it says, we understand that students are worried about request of classes for next year for scheduling. It says because of the initial deadline, which is Sunday night. It says, could you let them know not to worry about selecting their classes on your websites or on their websites? the deadline has been extended to April 30th. So once again, the request for the classes for next year, it has been extended to April 30th. So make sure you snap, Instagram, tweet, kick, whatever it is you guys do, send that to people to let them know the date was extended to April 30th. And they're working on something to send you guys. Then they're going to be emailing that out to you guys. So don't worry about it. All right. So just wanted to let you guys know. All right. And to finish off, once again, our objective for today was I can graph exponential functions. Did we graph exponential functions? Let's go. Show me with your fingers how comfortable you are with these. 1 through 5. 5's right. Good. All right. So once again, guys, make sure you stay focused on your academics, your work at home. Be nice. Remember to be nice at home to your parents and everyone there. And like I always said, if you're not moving forward, then you're already behind. Bam. All right, guys, have a good one. Love you guys. Keep up the good work. All right. Peace.